Hello everyone. Energy harvesting research and experimentation. Excuse me. Okay, so I was thinking about what I'm going to call the circuit interrupter, which is what this will be is imagine. Oh, here it is here. I'll just show you the drawing here. So imagine this. This is our generator, right? And I realized here, I think I put it in the description, I realized here that there would need to be a full wave bridge rectifier in this one. This is the generator. So in a generator, which is a motor, a brushed motor, for example, like these, we use something like this, right, a brushed motor. If I was using this as a generator, so it has two wires and it has brushes inside. This is a larger brushed motor. It has brushes inside here. So the brushes are here, and when we spin this, right, and it has magnets and coils inside. When we spin this, it'll give us a voltage, and it'll give us current, and there's a load on this. See if I can get this to focus here. And if this is connected to, if this kind of motor, if you want to use it as a generator, if we're connecting it to a battery, the motor would spin. But if we want to turn the motor and charge the battery, then it needs to, I would use a full wave bridge rectifier to allow the energy to flow from the generator to the battery. And we would still use this, what I'll call a circuit interrupter. I'm just going to call it an interrupter at the moment. What I was thinking was, imagine this here, and I was thinking about it, and I was realizing that as another test, I could have many of these, right, so many of them, all the way around. And each time it changed to a new, each time it turned a little bit, just a little, it would be disconnecting and then reconnecting the circuit on both sides, right? Here and here. So, and the reason for this test is because, as mentioned previously, I want to see if interrupting one of the wires, it could be the positive or the negative, and I want to try testing both, allows the resistance that builds up in the, what I'll call the generator, which is basically also an energy pump, right? It's pumping energy from the environment into the circuit, right? Thomas Bearden's research, which I'm still studying and learning about. So would this have less back EMF or drag, or would it be easier to turn with this spinning and this circuit being interrupted momentarily on each side as it spins? So this is a conductor. It could be a wire, it could be anything that conducts electricity. But when this spins, this circuit would be interrupted, and then it would reconnect as it passed by here. And if amps come first before voltage, could that help the battery charge? So what happens if I spin this slowly? What happens if I spin it fast? And at various different RPMs, including the generator as well. I imagine I want to spin the generator very fast, but maybe there's an ideal RPM, which is revolutions per minute, times it makes a complete circle in a 1 minute in 60 seconds, right? Now we're going to draw go to a new page, and we'll draw the interrupter. Let's say we're going to turn this counterclockwise. This is our generator. Let's say plus and minus. Let's say that goes into a full wave bridge rectifier. In, and then let's say plus and minus out. We'll send the minus through the circuit, and we'll send the plus over this wire. Right? So it's not touching, it's going over it. These wires don't touch. Okay? And we'll go over to the battery that we're going to charge. And in this instance, we'll say the battery is going to be 48 volt. It'll be a lithium battery. And that's a electric bike battery. That's what something I want to test and experiment on. So a fully charged would be, let's say fully charged equals 54.5 approximately volts. And if this is our battery, we'll say the plus is here and the minus is here. So this is the plus, which will connect to the battery plus, and the minus will go through this circuit here. So this is spinning. This is just could be a flat board, wooden board, circular, with a piece of metal or wire that goes through here. Now what I was thinking about as different from the previous page, and again, we have now the full wave bridge rectifier. That's this here, to allow the energy to flow in one direction, right? Because if we connect the generator to the motor directly, even through this, when it connects, it's going to want to make the motor spin. So this will help the energy to just flow one way. This will. Okay, so now what I was thinking today was, instead of just having one, right? Because then here we have, this is the negative, right? And then here we have it go to the negative. But instead of having just one, this spins, right? Instead of just having one, we could have many. This is not going to be perfect, so just to get the idea though. And these wires wouldn't actually touch here. If these were wires or whatever conductor these are, they would not actually touch one another. This is just showing an idea of the pulsing of this energy, interrupting it. Connect, disconnect, connect, disconnect. Okay, so we do not have perfection here, but we get the basic idea of another possibility. This would allow a lot more pulses of energy. So if we're spinning this at 1,000 RPMs or 2,000 RPMs, and when the circuit is being completed, every time this reaches a new point in this circular motion, okay, one idea is that this could be a ball bearing that rolls on a wheel that has conductors at different points. That way it would not wear out. Well, the ball bearing could still be damaged though by the sparking if there's big sparks here. I'm interested also in how to minimize the sparks, if there is sparks here, and maximize the charge and minimize the back EMF. Right, that's the main thing that I'm thinking about, is how do we minimize the resistance of this motor spinning, because I don't think we have to have resistance or back EMF. I don't think it has to interfere with the process of charging the battery. Okay everyone, have a great day. Bye.